Assalamualaikum friends, in today's video I will be talking about aminoglycosides, its mechanism of action, bacterial resistance shown to aminoglycosides, some common properties of aminoglycoside, and lastly I will end the video by talking about the adverse effect of aminoglycoside. So first we will start from the members of aminoglycoside. So the members include amikacin, tobramycin, neomycin, gentamicin and streptomycin. Now one thing is that the aminoglycosides end with the word mycin, but you don't have to confuse it with the other drugs because some other drugs also end with the word mycin. But how you're going to remember these members, remember at CNG pump. So A will indicate the amikacin, T will tobramycin, and I just replace C by S. So S will represent the streptomycin and neomycin and G gentamicin. So once again I will repeat: amikacin, tobramycin, streptomycin, neomycin and gentamicin are the members of aminoglycosides. Here the drug streptomycin, it was the first aminoglycoside that was discovered in 1944. So the first aminoglycoside discovered was streptomycin and it was discovered in 1944. Now we will move onwards towards its mechanism of action. So here you can see they are basically bactericidal agents, means they kill the bacteria, and they are protein synthesis inhibitor, means they kill the bacteria by inhibiting the protein synthesis. Now through for their transport they first enter through poring channels, and for the entry into the cytoplasmic membrane they require oxygen, so they are oxygen dependent. So therefore they are bactericidal for aerobes and negative aerobic bacteria, right? Why? Because they need oxygen. So the anaerobic bacteria, they show resistance to aminoglycoside. And why? Because anaerobic bacteria doesn't have the oxygen. So if there is no oxygen, the aminoglycoside can't enter and can't pass through the cytoplasmic membrane and can't then show their effect. So therefore oxygen is much essential for their action. In anaerobic bacteria there is no oxygen, so anaerobic bacteria show resistance to aminoglycosides. So aminoglycosides are effective against gram-negative anaerobes. And how you're going to remember that they are effective against gram-negative? So for that, if you can see, there is N in aminoglycoside. So from N you can just pick the point that they are active against gram-negative bacteria. Okay, now moving on towards its mechanism of action. So they enter into the cytoplasmic membrane, and for their entrance oxygen is required. Now once they get entrance into the cell membrane or cytoplasmic membrane, they bind there to the 30S ribosomal subunit. And some bacteria bind to the 30S, some bind to the 50S. How you're going to remember that? I told you in my previous video that just you have to remember it by at 30 and cell 50. So they're at tetracycline and aminoglycoside, they bind to the 30S ribosomal subunit, and the other ones they bind to the 50S ribosomal subunit. Okay, so once they bind to the 30S ribosomal subunit, they cause two functions. Once they inhibit the initiation of protein synthesis. In initiation, formation of initiation complex is the first step in the transcription process. So they inhibit the initiation of protein synthesis, and the other function of them is that they cause misreading of codon. So when they cause misreading of codon, what happens? There is premature termination of protein synthesis, and there is insertion of wrong amino acid into the growing peptide chain. Now what they result in the formation of defective protein. Now once defective protein is formed, they then incorporate into bacterial cell membrane. So incorporation of defective protein into bacterial cell membrane alter the permeability of the cell membrane and cause disruption of cell membrane, and thus shows their bacterial bactericidal effect. So it was all about the mechanism of action. Now we will talk about some common properties of aminoglycosides. So here you can see they are highly polar compounds, means they are hydrophilic in nature, and if a drug is hydrophilic in nature, so their absorption through GIT tract is not that much efficient. Therefore, for their efficient effect, or you may say for their systemic effect, we give them through parental route, means either intramuscular or through intravenous route. Now the other is that they are not metabolized in the body, and thus they are excreted unchanged in the urine. And this one I talked about that they are bactericidal, and they are bactericidal against gram-negative aerobes. And the other thing is that they are more active at alkaline pH. Okay, now transport of aminoglycoside into bacterial cell require oxygen. This was also discussed by me. Hence anaerobes are resistant to aminoglycoside. Okay, now they show synergistic effect with beta-lactam antibiotics. Here you can see aminoglycosides are often combined with beta-lactam antibiotic to employ a synergistic effect, particularly for the treatment of gram-positive infections. Now when the effect of two drugs increases, so we call that effect synergistic effect, right? So beta-lactam antibiotic basically are the cell wall synthesis inhibitor. So aminoglycosides, when beta-lactam is given along with aminoglycoside, so beta-lactam just break down the cell wall, and thus the entrance for aminoglycoside is then easily, as because the entrance for aminoglycoside in gram-positive bacteria, I think no, it's not. Okay, just leave that. Okay, so once the cell membrane is broken down, the entrance of aminoglycoside into the cytoplasmic membrane, it is then means it increases its efficiency, or the beta-lactam antibiotic increases the transport of aminoglycoside into the cell. Okay, so this was all about the common properties. Now we are going to discuss the mechanism of bacterial resistance. So bacterial resistance to aminoglycoside may be due to inactivation of drug by bacterial enzyme. For example, there are certain enzymes produced by bacteria, and when a drug is taken, the enzymes they break down those drugs, and thus those drugs are then ineffective against the particular type of bacteria. Therefore, this is one type of bacterial resistance, means bacteria show their resistance by producing certain enzymes, and that enzymes are then used to degrade or break down the drugs. Okay, now decreased entry of drug into bacterial cell wall. So if there is decreased entry of drug into bacterial cell wall, the drug will also be not effective against that particular bacteria. Decreased affinity of the drug for the ribosomes. Also, if there is in certain bacteria, if there is decreased affinity of the drug for the ribosomes, then the drug cannot show its effect. Okay, now here two things is that aminoglycoside are concentration dependent, means the higher the aminoglycoside concentration is, the more bacteria it will kill. And the other thing is that they show post antibiotic effect, means bactericidal effect is present even when serum concentration fall below minimum inhibitory concentration. Means if the aminoglycoside concentration in the serum even falls below the MIC, so it will still show its effect. Okay, now we have some adverse effects, and that are the ototoxicity, nephrotoxicity, neuromuscular blocking effect, hypersensitivity reaction, means skin rash, etc. Okay, For that, the word is HNNO. So H, hypersensitivity, and nephrotoxicity, and neuromuscular blocking effect, or ototoxicity. Now, ototoxicity may be because of vestibular dysfunction, or it may be due to cochlear dysfunction. In cochlear dysfunction, we see tinnitus and deafness, while in vestibular dysfunction, there is intense headache, dizziness, nausea, vomiting, vertigo, and nystagmus and ataxia. So these were all the adverse effect of aminoglycoside, and this was all about aminoglycoside from my side. If you like my video, share it with your friends and subscribe must to my channel. Allah Hafiz for now.